Welcome everyone to the chemistry class. Students, we learned about covalent bonds and covalent compounds in the last class. Don't you remember? Covalent bonds are formed by the sharing of electrons, right? Today we are going to learn a new concept from this chapter. Shall we start? The electron pairs shared in a covalent bond are attracted by both the combining atoms. In a covalent bond, the relative ability of each atom to attract the bonded pair of electrons towards itself is called electronegativity. For example, in the case of hydrogen chloride, chlorine shows a greater tendency to attract the shared pair of electrons than hydrogen. This is called electronegativity. The type of chemical bond between atoms in a compound can be identified. Let's get familiar with a new method, electronegativity. The electronegativity scale was proposed by the American scientist Linus Pauling. This is a relative scale with values for electronegativity of elements ranging from 0 to 4. In this scale, fluorine is the most electronegative element. Let's learn how to find the chemical bonding in a molecule using electronegativity. Consider sodium fluoride as an example. Identify the type of chemical bonding in this molecule, whether it is ionic or covalent. You know the constituent atoms present in sodium fluoride are sodium and fluorine. And the electronegativity of sodium is 0.93 and that of fluorine is 3.98. Now we have to find the difference in electronegativity between sodium and fluorine. That is 3.98 minus 0.93, which is equal to 3.05. Using this value, how can we identify that given compound is ionic or covalent? If the difference in electronegativity values of elements in a compound is 1.7 or more, the compound generally shows ionic character, and if it is less than 1.7, the compound shows covalent character. So here in sodium fluoride the compound shows 3.05. That means it is greater than 1.7. So sodium fluoride is an ionic compound. Some compounds and their nature are shown in table. Complete the table. The first compound is carbon monoxide. The difference in electronegativity of constituent element and the nature is to be found out. Second one is methane, CH4. The difference in electronegativity of constituent element is not given and the nature of compound is covalent. And the third compound is magnesium chloride, MgCl2. So you have to find out the difference in electronegativity of constituent element and the nature of compound. In the case of carbon monoxide, the difference in electronegativity of constituent element is equal to 3.44 minus 2.55 is equal to 0.89. Hence carbon monoxide is a covalent compound because its value is less than 1.7. The next one is methane. The difference in electronegativity is 0.35. So again this compound is also covalent. And in the last one, magnesium chloride, if we find the difference in electronegativity, we will get 1.85. So we can say magnesium chloride is an ionic compound. Let's see what happens when the atoms become highly electronegative. Look at the example hydrogen fluoride. Here the electronegative value of hydrogen is 2.1 and that of fluorine is 4. Since fluorine is being electronegative, it attracts the shared pair of electrons towards itself and it acquires a partial negative charge, delta negative. and the hydrogen atom develops a partial positive charge, delta positive. As I told you, the fluorine atom having a higher electronegativity attracts the shared pair of electrons towards its nucleus. In the case of hydrogen chloride, chlorine atom having a higher electronegativity attracts the shared pair of electrons towards itself, hence it develops a partial negative charge. Such compounds having partial electrical charges within the molecule are called polar compounds. Examples HF, HBr, H2O, etc. But in the case of H2, N2, etc., the two atoms are homodiatomic. That means they have same electronegativity values. So they attract the shared pair of electrons equally. So it won't result in a partial electrical charges. These type of compounds are called non-polar compounds. There are certain other molecules, especially polyatomic molecules. The geometrical shape of a molecule is a factor that determines its polar nature. Water, ammonia, etc. are such compounds. The difference in the nature of the chemical bonding reflects in the properties of compounds as well. Let's learn the difference between ionic and covalent compounds. Ionic compounds exist in solid state, whereas covalent compounds exist in solid, liquid and gaseous state. Second point, ionic compounds are generally soluble in water, but covalent compounds are soluble in organic solvents like kerosene, CCl4, benzene, etc. Third point, ionic compounds conduct electricity both in aqueous and molten state, whereas covalent compounds are poor conductor of electricity. And the last one, ionic compounds have high melting and boiling point, but covalent compounds are usually having low melting and boiling point.